My name is Leon, I'm a sensor specialist, and in today's video we will look at what options we have to create a high precision 3D scan of a part. Once we clarified the general options, we will compare them and look at the advantages of each option. This will hopefully give you a better feeling for what option might be the best one for you. So let's start. Of course we can perform a 3D scan by using a 3D sensor, but we can also use a 1D or 2D sensor. For each dimension that the sensor is missing, we simply need to add a moving axis. So for a 1D sensor, for example, we need a 2-axis stage, because the one dimension of the sensor combined with the 2 axes of the stage again makes up 3 dimensions. And if we were to use a 2D sensor, then we'd only need a 1-axis stage, or we could put the target simply on a conveyor belt, for example. The 2 dimensions of the sensor with 1 dimension from the stage or the belt again gives us a total of 3 dimensions. So you can see that you don't necessarily need a 3D sensor for performing a 3D scan. The 1D and 2D sensors are also being used for 3D scanning since they all have their own advantages. We will now compare some of the most important characteristics so that you get a better feeling for what option might be the best for you. And if any questions come up while you're watching this video, just leave a comment, or alternatively you will find my contact details in the video description below. While comparing all these characteristics, I will grade the options by using a plus sign, a 0 and the minus sign, with the plus sign being the best grade. We already talked about the number of axes that we need for each option, and since the 3D sensor doesn't need any additional axes at all, it will get the best grade. The 2D option will get the second best grade, and the 1D option will get the worst grade of all 3 options since it needs 2 additional axes to create a 3D scan. When looking at the sensor size and weight, you will notice that the less dimensions a sensor has, the smaller and lighter it can be. And since space is typically always of concern in production lines, the 1D sensor will therefore get the best grading here. So if space or weight is a big concern for you, then try to go with a 1D or 2D sensor. Next up is the speed. As you can imagine, the more dimensions a sensor has, the less time it takes to finish a full scan. A 3D sensor can often scan a part within a second, while a 1D sensor will typically take several minutes for the same part. And this is even true if we're using a high-speed sensor with a 30 kilo sample rate, for example, since the 2-axis stage will have to move back and forth hundreds of times to scan the full part. And that movement takes quite long, as the stage needs to accelerate and decelerate every time it changes its movement direction. The 2D sensor has the advantage that only a single axis is needed, and therefore there is only one continuous movement direction, which can make the scan extremely fast again. So if speed is of concern for you and you need the full 3D scan to take less than a minute, then you should look into the 2D and 3D sensors. Then let's look at the resolution. As mentioned before, some options need additional moving axes to create a 3D scan. And whenever an additional axis is needed, the resolution along this axis is defined by the resolution of this axis and not the sensor. Therefore, the 1D sensor will be able to provide you the best X and Y resolution, since these resolutions are only limited by the stage. If the stage can move in 1 micron increments, for example, then you could theoretically get a 1 micron X and Y resolution. For the 2D sensor, it is the same for the moving direction of the sensor, but along the direction of the laser line, it is limited by the amount of points of that line. If we look at the Micro Epsilon LLT 3000-25, for example, it has roughly 2000 points along its 25mm wide line, which means the resolution in this direction is about 12.5 microns. And for the 3D sensor, the resolution of all axes is defined by the sensor. Here the resolution depends a bit on the measuring area, but typical resolutions are 30 to 100 microns. So while the 1D sensor of all options can provide the best resolution, note that there is a correlation between the resolution and the speed. To give you an example, let's say we have a 3D sensor that can scan a 50 by 70mm target with an X and Y resolution of about 50 microns in roughly 1 second. Then every 50 microns you will get a measuring point, which means you've scanned 1.4 million points in 1 second. If we would now use a 1D sensor with an extremely high sampling rate of, for example, 50 kilo samples, then mathematically speaking, the scan would take at least 28 seconds. And it would actually be way more than that, since we didn't account for the acceleration and deceleration of the stage. Additionally, the movement speed of the stage is also limited. So the scan with a 1D sensor is more likely to take several minutes. If we would now want to increase the resolution past the resolution of the 3D scanner, then the scan time would be even higher. Therefore, only go with the 1D sensor if you really need this extremely good resolution. By the way, I didn't mention the Z resolution yet, but it is typically always in the single-digit micron range for all three options. The next characteristics we want to look at are the sensor price and the setup price. The more dimensions a sensor has, the more complex it typically is, and with that comes a higher price. But keep in mind that for a 1D sensor, for example, we still need a 2-axis stage. So while the sensor price itself might be smaller, the costs can equal out if we look at the whole setup. And if you combine a high precision 1D sensor with a high precision 2-axis stage, then you will even end up with higher total costs compared to a 3D sensor. The combination of a 2D sensor with a 1-axis stage might even be the most cost-efficient option, and if your products are already moving on a belt, then you don't need the 1-axis stage anymore, but only the sensor, which makes the whole setup even more cost-efficient. So the price really depends on the other factors that we talked about and also on your overall setup. Then we should quickly discuss 3 integration topics. First up is the inline capability. Due to the long scan times, the 1D sensor is typically not used for inline scans unless your cycle time is several minutes long. The 3D sensor is perfect for inline scans if you can make the line stop for a second, because the part needs to stand still while it is being scanned. And if you cannot make that happen, then the 2D sensor is the best option for you as it measures continuously. The second integration topic is the target size. The 1D sensor is usually only used for very small targets with microscopic structures, typically less than 10 by 10 millimeters, as everything else just takes too long to scan. The 3D sensor can reach up to around 150 by 250 millimeters, so you would use them if you quickly want to get a full 3D shot of a larger area. The 2D sensors can go even wider. There exist some sensors with a laser line of 600 millimeters, and if you combine this with a conveyor belt, then you can even measure continuously. So only the width of the part is really limited, but the length is unlimited. And the last topic we should talk about is the integration complexity. If your setup includes some sort of axis or moving belt, then you will need an encoder for each single axis, and the encoder needs to be connected to the sensor, because you want to make sure that you know the exact point-to-point spacing in your final scan so that it is not distorted. Additionally, keep in mind that some systems might have slippage that you need to account for. If your conveyor belt system is friction-based, for example, then the integration process of a 2D scanner can become quite complicated all of a sudden. So you can see that there are a lot of things to consider when it comes to 3D scanning, and they all depend hugely on your application. We didn't even talk about the various different technologies within the 1D, 2D and 3D sensor group, but they will also have an influence on your final scan. Therefore, it is important that you discuss your application in detail with a sensor specialist that has knowledge of all these options. And if you don't have a sensor specialist on your side yet, then feel free to contact me. You will find the contact details in the video description below. With that being said, I wish you all the best with your 3D scans.